I'm a mathematician, marine biologist, which is a very weird mix I can appreciate. My daughter calls me the mermaid mathematician. But what that's done over the last 20 years is give me an appreciation for the way that marine ecosystems work. And as you can see, given you're getting my view of the world, there's not very many fish that you're going to see in the rest of this talk. It's actually about the way that we need to think about this world. So, back when we were just evolving as a species, and all for the many millions of years that we were Stone Age people, we developed what we call linear thinking. So we have this vision in our head of how the world should be, and it's fixed around a certain ideal spot. And the way that we think that the world will work is that it'll change in little bits from that spot in a smooth line that we'll be able to anticipate. So that's fine if you live in the ancient world and you don't have very many things and very many scales to have to think about. The problem is that it also means that when you think about something, it's a very linear response that you're thinking about. So if you're cold, for instance, and the world around you gets colder, then you get more of that feeling. So it's a very smooth idea of the way the world works. And that vision of the world is also based around the idea that if you change the circumstance, you get a very, very quick response in the way that the world that you're experiencing changes. So if you build a fire, you get warm pretty fast. It's also based around whole sets of simple rules. So we have, as a species, a fear of animals with big sharp teeth and big eyes. That's because they used to eat us. And if you didn't follow that rule, you got eaten and you didn't have any babies, and then people who didn't follow that rule didn't live. So there was a very, very strong evolutionary pressure on us to follow simple rules. If you see this, do this, because if you didn't, you die. The thing is that the world that we live in now is working on different scales. So there's enough of us on this planet now that we can affect the whole of that Earth system. So this is a picture from NASA that we've probably all actually seen, where they've brought together lots of night photos from satellites and showed that there's a very big footprint. You can see in North America and Europe, there's almost nowhere where there's no light, where there's no human impact on that system. And for any people who doubt that humans can have an impact on that big Earth system, we're all each individually very small, how could we impact something as big as the Earth and its climate? Well, the ozone hole is a pretty good example of how we've already done that. It's a good example in two other ways too, though. It's an example of how we didn't freeze up, we didn't become overwhelmed with the enormity of the task ahead of us. We actually went out and changed our behaviour. Despite all the economic hoo-ha that the world would end if we changed our manufacturing ways of doing things, we did. And we've lived, technology's moved ahead, ozone hole is being repaired. But that's where it comes to the other second point that I mentioned that's important about the ozone hole. It didn't heal itself overnight. It's going to take many decades yet, if not a century or more, to heal. And that's very typical of ecosystems. They take a long time to respond. It's not that immediate response our brain is tuned to think about. So what we really need to do, and this actually appears to be a theme appearing in a lot of the talks today, is we need to think about life as eternal change. So it's not just that there's been dinosaurs in the past and there's not today. It's not just that the way that technology is moving on. So we've gone on the oceans from, people with rowboats and sailboats to steamboats. So the top picture there is of a trawler 100 years ago. They used to have steam-powered trawlers off New South Wales. Today we have high-powered boats, such as the big tuna boat on the bottom. But ecosystems change too. So the top picture is that of a coral reef. So the bottom picture is, people are probably expecting me to say what happens when humans interact with coral reef. It's actually what happens when a cyclone interacts with a coral reef. Ecosystems change whether we're here or not. So we need to think about what that means if we're putting extra change on the system. So if we think back to that linear world of the way our head thinks the world works, that there's a spot to aim at, ecosystems don't sit still. They bounce around like a ball inside a squash court. So how do you actually cope with that if you're going to sustainably use them? Well, the first one is, the first rule we have to break on our little list of rules is that more is better. So because of that very linear way of thinking of the world that we have in our head, which is actually as much a result of our education as a result of the way that our brain works. So it was very physics-driven education for the last few hundred years. We need to get into the new form of physics. It's a bit more variable. So this is a picture of northern Tasmania during a big bloom. So if I can manage to drive this without destroying the joint. There's actually a big bright blue thing up there. That's actually a big algal bloom. And what's happened there is there's been large winds, it's drawn up cold water from the deep ocean up near the surface. It's brought nutrients with it, which is phytoplankton or little ocean animal, little ocean plant food. There's been heaps of those little plants grow, which has left this colour on the surface of the water. It's brought that in turn acts as food for shrimps and prawns and things that eat phytoplankton, which in turn become food for zooplankton and fish, and the whole way up the chain to us. So when you get a big bloom like that, you're likely to actually get higher fish production, which keeps fishermen happy and all that kind of stuff. So it sounds like nutrients are good. So in our little list of rules, it would be more nutrients equals good. But unfortunately, more nutrients doesn't always equal good. This is a picture from a State of Environment report from a place near Sorel about 10 years ago, where there was a freshwater from a big rainfall sat on the surface and kept nutrients there, and a big algal bloom formed. And in this case, algae wasn't good because it drew down the oxygen. When the algae rots in the water, when there's too much of it, the oxygen disappears, so then the fish die. So we have to break away from our simple rules. Having just a simple response to something isn't always going to be the way that the world works. This is where my computer decided. Oh, there we go. So we have in our heads the very simple rules of the way the world works. We need to get away from that, because the way that ecosystems work is they have lots of rules. It's almost like they have a menu of rules. And at sometimes one rule will be dominant, and another time a different rule will come up. So it could be that the primary producers, the plants in the system might be dominant. They might be feeding up what's called bottom up. They're the food and they feed up through the system to support the fish and shape the way the ecosystem is. Other times it'll be the climate and the environment, so whether it's getting warmer will shape the way that it is. So you could have species moving in from the north, much like we have Centris stephanus, the urchin, coming down from the north. And other times it's actually what they call top-down, where the predators and the consumers in the system get to dictate that. For instance, the way that we change the world can be a top-down process as we eat up seafood and that kind of stuff. So you can see there's not one set of rules. It'll change year to year. Sometimes there's blooms, sometimes the winds change. If you're a fish, you don't know whether 1 million of your babies are going to make it to be fish or if no babies are. There's year-to-year variation in orders and millions of individuals. So what that means for management is we have a fundamental problem with the assumptions that we're making. Because of that physics background in our education, we assume that that linear world will work. So we all hear about getting back to a pristine ecosystem. That there's some spot that we can aim our management at, and we can just make a concerted effort to get rid of uncertainty, find what that pristine environment is, and move back to it. So it's a bit like saying that there's a person juggling and he's got to do everything he can to keep that one ball in the air. Unfortunately, ecosystems aren't going to work with him on that, because of all those different rules and one cropping up at one time and different rule cropping up somewhere else. There's lots of balls in the air. We can't be certain. So when you say we can't be certain about something, whether you're a person on the street or Prime Minister Rudd, uncertainty makes you freeze up. Our brain doesn't like uncertainty. It wants to be absolutely sure about that rule so it doesn't die. Unfortunately, that same uncertainty, that same freezing up response is going to kill us this time if we don't change the way that we do things. So it can be simple to say, well, we can maybe imagine what it's like without us. That still leaves a lot of balls in the air. We can maybe get rid of the ones that aren't going to be possible in the future under climate change. Still left with a lot of balls in the air. So we've got to change the way that we do things to help us juggle so that we can keep all those potential balls in the air. Because if we wait in the hope that we only get to one ball so we don't make a mistake, we're actually going to drop all the balls. So we've got to start dealing with uncertainty and learn to be jugglers if we're going to successfully get our ecosystems to support us into the future. And the reason that we have to do that is that old vision of there's a pristine world, there's a very fixed way to get to it, has let us down really, really badly. So this pie chart represents the state of the world's fisheries. So we've got the fisheries is about a third of the fisheries in the world are what they call overfished. So that means that the fish they're trying to catch, there's not very many of them left. There's not enough for it to be a sustainable population. In those particular fisheries, they have made the effort to get rid of the excess pressure from the fishermen. So they're trying to rebuild them, but they're not there yet. The bottom third down here, they still actually haven't even fixed the problem yet. So for 2/3 of the fisheries on the planet, there's not enough fish, and in some cases we're still not trying to fix the problem. For the last third here, they're an interesting mix. Some of them are ones that haven't developed yet, often jellyfish fisheries. There's more jellyfish fisheries in the world than I think you'd appreciate. But that's not something I find overly appetising. On the flip side, there are some good news stories. It's not all the doom and gloom that people in the media would like to paint. When we hear a doom and gloom story, we go back to that uncertainty and we freeze up again. Don't be afraid. We can actually do things if we change the way that we think. And one example is from Australia, actually. Some of Australia's fisheries have turned around. They are recovering. On the coral reef front, we're not doing much better. So again, there's about 1/3 of them that are absolutely severely damaged. There's another 1/3 that are threatened, mainly because of human activities, including increasing bleaching events. There's about 1/3 that are currently in good condition. The twist in the case of coral reefs is that with ocean acidification and rising temperatures, by the middle of this century there's unlikely to be any coral reefs that aren't threatened. It could quite possibly be there's nowhere on Earth that's safe to be a coral anymore. There are some people saying that they'll adapt, and there's a possibility for that, but we have to, again, do that juggling to give them the scope to be able to adapt. So to give you an idea of what climate change might bring, this is a little cartoon of what the world currently looks like. So if we think about the tropics up here, so if you're going to Townsville, you'd be at this end of the picture, and Victoria, Tasmania is down this end. So down this end we've got all the cold water fish and the cold water kelp beds and things like that. Up this end we've got dugongs and coral reefs. So if that's like what it's like today, then in the future it'll look like this. You can see that everything has shifted to the south, towards the temperate end. So we've got tropical species coming further and further south. We're actually already seeing that. There's been, across the world, a 50 to 500 kilometre shift in where marine species are going. They're going towards the poles, which sounds fine in some places. You get tropical water further south, it'll be warmer to swim off Tasmania. But what happens when those temperate species hit the bottom of Tasmania? Where do they go? They run out of space. So there are big issues about biodiversity. There'll be some places that get more biodiverse, there'll be some places that get a lot less. The other thing you might have noticed is that there's these little winged white things in there. That's a little cartoon for any kind of plankton that has a skeleton. And you can see that under ocean acidification, they're actually a lot rarer, as are the coral reefs. So it's not just that it's the temperature that we have to worry about, it's actually how acid the ocean's getting. We can't tell you exactly what the world's going to look like. It's changing faster in ways that we just have never seen. There's always going to be a surprise, no matter how good the models get. There's always going to be surprises about what's coming. And that's why we can't wait to be absolutely certain, because by the time that we wait that long, we've left it too late to react. We have to learn to be jugglers now. It's not actually as hard as that might sound, though. You'd think that, fighting millions of years of evolution and decades of education and all that kind of stuff is going to be hard, but it's not really that hard in the way that we already live on a much smaller scale, despite the way that our brain thinks. So whether you're learning to ride a bicycle or you're learning to use one of the fancy cars that we've seen, the way that we deal with the world is that we plan what we're going to do it, we see if it worked, and then we might change. If we're a good driver, hopefully we at least learn to change our behaviour through time. We need to do the same as we drive the planet, basically. We need to define what we want out of it. We need to put those plans in place, check if they worked. If they didn't work, or the ecosystem is changing in ways that we didn't know about, or if we get a surprise, then we need to adjust what we do. We need to keep going around that circle, because it's the only circle, the adaptive management cycle is probably the only way that we're actually going to make it through what we're facing. So in the world that we're about to go into, it's changing more rapidly than at any time probably in our species history. It's not just that the climate itself is changing around us, but our society is changing. We're in the midst of a revolution that's probably only on a par with the revolution to form agriculture and the Industrial Revolution. What the information revolution means for us is that it's chaos and it's changing and it's uncertain, and we question ourselves. We like to actually buffer ourselves in little lies about understanding the way the system works. But we can't, it's changing too rapidly. We're going to shoot ourselves out a trapdoor that we can't get back through. So to deal with that, we have to learn to adapt. We have to take that lessons about learning and doing to even deal with ecosystems. So first of all, we have to learn not to be afraid. When we hear something uncertain, we go, fine, it's uncertain. What have we got to do to learn to juggle instead of try and keep that one ball in the air? We have to accept that change is always going to be upon us. It's not something, as much as it might seem a pain to have to deal with change, it's something that we're just going to have to learn to live with, to adapt with. What that means for management is that for anyone who's a fisherman or likes to go swimming or use the environment, the rules that we employ are going to have to change, not just from country to country with the different cultures that are going to have to deal with it, but also through time in any one spot. So to us, we like to say, right, we fix that problem, tick, move on to the next problem. It's not going to be like that anymore. It's going to have to be, right, they've changed the rules again because they need to change them. We can't just get stuck in one sort of management. But I don't know about you, but I think it's really worth it if we actually manage to do that, though, because it'll mean that we end up with an ecosystem that will support us and have a place for us into the future.